Hello, everybody. Welcome to Digitalwerx TV. I'm Steve Johnson, and there was kind of a cliche. I was calling everybody a special guest, but I think you guys are special guests. Jody Singer and Chris Singer. Jody is the former director of Marshall Space Flight Center. You were the former acting director. You were the former assistant director, and before that, you worked on human space flight, the space shuttle, the return to flight after the Challenger accident. You joined NASA back in 1985, and you were a native of Hartselle.
That's correct.
Which a friend of mine says is extremely important to mention. Okay, Chris Singer. By the way, you guys are husband and wife. Let's get that out of the way. It's not just a coincidence that you have the same last name. Now, Chris, you were a 30-year NASA engineer. At one point, you were the deputy chief engineer for the entire agency. Is that correct?
That's right.
Okay, so you retired before Jody did. And started your own company, and you were doing consulting work for, I'm assuming, engineers and executives.
Well, yes, and coaching. So executive leadership coaching. So that really became my passion when I left NASA after Jody got her promotion, was to get into the not just the technical side, but the human side.
Yeah. Now, anybody just who is married would say, well, how did that work when she was the director of Marshall Space Flight Center and you were working at Marshall Space Flight Center? So who would like to answer that? How did that work?
I think he should go first and answer that.
Well, actually, I got a call from the associate administrator that they were going to select Jody, and that what was I going to do?
And, my job.
And because they didn't want me to work, because I was the engineering director at Marshall, and they didn't want me to work for her directly. And I said, well, guys, I guess, what do you want me to do? He said, well, you could be deputy chief engineer for the agency and work for headquarters. And so that's what I did for a year and a half after
Which
Jody
really
got
gave
selected.
you a lot of good exposure and a different way of viewing things that
it opened up some
may or may not have had just working at Marshall.
Opened up some trade space for me. So I have to thank her for getting me fired.
Okay, well, I do want to mention, and I hadn't mentioned this yet.
You're welcome.
That you worked on you were part of the recovery after the Columbia shuttle disaster, and after the Constellation program, which was going to be the replacement for the shuttle after that program was canceled.
Yeah.
So I don't know if that feels like it needs recovery to just the general public, but it needed some recovery because everybody was headed one way and stopped and had to head another way, which ended up being SLS.
Yeah, well, the Columbia is its own story.
Yeah.
But when we leaned forward into Constellation, which is going to be the next lunar missions, and when it was canceled, we had probably 1,500 people working that program, and a lot of support contractors. We had to lay off over 600 people. So it was a big, devastating trauma, just like a catastrophe.
Oh yeah, I mean, and if you're really going all the way back to the Saturn V program, and everyone forgets that by the time we landed on the moon, people were losing their jobs.
Already getting laid off.
I've been losing their jobs for a couple of years. Mm-hmm. That the space industry tends to be a little bit up and down, doesn't it?
It can be. It can definitely be. Most times it's for the contractors, the support contractors. But in the case of Apollo, and one of the things we're experiencing now is some of the civil servants are also, we're seeing, a reduction in force, or people choosing to take a buyout.
Now, and it should be mentioned that Marshall Space Flight Center is historically a development center. It feels more diverse than Joseph Pelfrey would say. It is more diversified now. There's more going on. Absolutely. There are a lot of things going on, but they are essentially development things. So being able to develop things is really cool. It got us to the moon, but still it does, well, it's developed. What are we going to do now? Does that come up?
A good little bit. I mean, Marshall is known for good design and development, knowing, how to build, and not just rockets. I mean, you go back to telescopes, to what we did on space station, a lot of the things. So there's a lot of design and development, understanding materials, propulsion, you name it. So that's value added. But with what we do, cheating gravity, it's hard to say that you just go cross a line and you're from development to operations. So our hardware is always humbling. So even though we do design and development, you still got to maintain it and you've got to operate it. And that hardware usually throws us some curves on its performance. So it's good to stay not only in sync with the design and development, but also getting it to a maturity so that you can maintain the safety, particularly when you have astronauts on board. You've got to understand that hardware, and then you reach more and more of a state where you become more and more operational. But many of the times, every mission is different. But yet, that is really critical, understanding that operation. But there's a lot of things that we do from a Marshall Space Flight Center that's operational.
I like that we thing.
It is what we do.
No, but everybody I've ever talked to who worked at Marshall, they've been gone 10 years. It's still we.
Hey, it's we. It's always a team effort, and you're always, supporting it. And our ability to operate, is very important. International Space Station, the things that we do on, the environmental life support system, payload ops. The science that we get. There's a lot of things that are operational, but yes, in answering your question, we're known more as a design and development. But we've had to learn how to partner with the different partners and how to do the operation and the acquisition strategy a little different. But that's one of the things that Marshall's always known is how to be resilient.
Okay, so, and the space shuttle, I think it needs to be mentioned, was once it was developed, it was still in constant development.
Absolutely.
Is that a fair statement?
Absolutely. The last mission, we were still learning.
Yeah, 135 missions
we
and
were
still learning.
And I think that's one of the dangers of space flight is that the more success you have, the easier it is to start believing that you've kind of found all the problems, and maybe you start losing a little bit of that technical curiosity. I won't call it complacency because nobody is complacent in the space flight program, but that hunger. And so we need, in my mind, even when you're in an operational mode, we need some development level energy. So to keep us curious about the hardware and what we're learning.
Yeah, well, that is kind of a theme that you can read in any number of books about. Success breeds, okay, that works, and since a rocket is basically a bomb with the end cut off, it's you can't ever really let yourself do that, can you?
You really can't. You have to be on your toes. But one of our mentors and one of the persons that a lot, Mike Rudolphi, who's no longer with us, but one of the things he would always talk about is, don't over polish the rock. So there's keeping safety in mind. There's understanding your hardware, making sure that you do everything you can to make it safe, but we've got to make sure that we don't over-polish because that also is not a good thing because the safest place is on the ground.
Yeah.
But that's not what space exploration is about.
No, and one of the things, going back to the German rocket team, the Germans would have probably still be testing. that's an exaggeration, but they believed they wanted to test more than they actually did for the Apollo program. And but money, as it does with just about everything, gets in the way, doesn't it?
And schedules,
Schedules.
right? Because when you got deadlines, we need to make certain milestones, and we could keep testing to make sure 100 next percentage. At some point, you have to make a risk decision.
Okay, so you guys are both engineers, and I would expect. You've worked on human space flight, and human space flight's not like sending a satellite to orbit. That rockets have to be human rated, and all that means that the chances of a disaster are pushed as far back as they can humanly be pushed. Is that right? When you human rate a rocket,
within the bounds of the programmatic constraints, and what I mean by that is there's not an infinite amount of money or time.
Yeah.
So we do what is possible within that range. You're balancing cost, technical schedule, and risk. Those are your four parameters. And usually you got constraints on
Yeah, and
those.
I'm just thinking as you're saying that, and that's exactly, I mean, that makes so much sense. As a director, Marshall, you would probably be asked, "Are you guys ready to go?"
Absolutely. Whether we were both on the shuttle program or
did you-
Artemis, you are getting asked, are you ready to sign off? And many of the times, I wasn't the one that knew everything about every element.
Yeah.
You had to rely on your people. And there's a process you followed to say, yes, we're ready to go. We've looked at a reasonable amount. There may be some risk. You understand them, but then you have to make the final decision along with many smart people that says, yes, to the best of our knowledge, we're ready to go. We're ready to go forward. And that is one of those things that I can say it right now, and I can feel it in my chest. I can feel it in my throat, that says, yeah, we've done everything we can to ready to launch. And there's one thing to be in a flight readiness review or the different reviews that you build up to a launch. And then when you get down to the Cape, the Kennedy Space Center where you're launching, and you go through that review process, and usually there was a break that we always took before you had to go through the poll, and then to see if there were anything that you saw that would change your mind, if someone didn't speak up that was supposed to. And then when you'd go through that poll, of go. And then I guess I'd say, and I can kind of hear in my own brain, the music rising. Then you get on launch day, and again, it's one of those things that you feel that pressure, you feel that responsibility, but you know that you and your team at the end of the day have done everything you possibly can to make it as safe as you possibly can. And majority of the time, that's true. But then when it's not, that's one of the toughest decisions that you always have that hindsight. And we have to make sure, that when that happens, that we discuss what happened and why, and try to make it better the next time so that we don't repeat those mistakes.
Doesn't that go against the grain just a little bit of the whole idea of being an engineer? That because, you build a bridge. You build a bridge. It's going to work. We built it. We designed it. But being an engineer and with rockets, you are having to say, okay, this is what we think, but we don't exactly know. Am I saying that correctly? It seems to me that there's a little bit. The engineers, they don't like guesswork, do they?
No. I mean, and there's a little bit of apples and oranges. And by the way, there's been plenty of bridge failures.
Oh, yes.
Over history.
Yes, and pretty much failures of everything.
Even with all of the factors of safety.
Yeah.
And what we often call them is factors of ignorance.
Yeah.
So we add margin to the analysis to cover some of the things that we don't know.
Yeah.
But in space flight, your margins are much smaller than in a bridge.
Yeah.
And that means that little errors can mean big problems.
Yeah.
And that's what we learned in the tragedy.
One of the things and you mentioned the readiness reviews and everything. I've been told before that when during the Apollo program they would have these big meetings, and they would go over things. And if somebody had a concern, and a NASA veteran, Alex McCool, told me, you were expected to raise your hand. They wanted to know. I'm not saying anything. It's like, you better say something. Mm-hmm. So does that continue even now, that kind of thing, where if somebody has a concern, you want to know about it if you're working on rockets?
Absolutely. I mean, you want to know. You want to know, even if, there's one thing when someone just throws out and says, well, I'm concerned about this, but they don't bring a little bit of information.
There's gotta be some
So
data
whoever
backing
brings
it
it
up,
up,
yeah.
you can't just say, I feel. There's usually some that goes along with it that says, this is why I'm concerned about this. So it helps to be able to bring the story versus just raising the hand. But it is important to get all the opinions on the table, to look at the folks in the room that are the quiet thinkers, that might not always be the one that raised their hands, to make sure to hear what they say. And that was one of the things that I used to do, and I know Chris did too with your team, that when you're on console or when you're at a readiness review or even reviewing a technical change, it's trying to get those people engaged.
Yeah.
and to make the eye contact. That's one of the things of having people in the room, to be able to go eye to eye.
I never thought of that. You mean,
watch the body
are
language.
you okay with this? Is that what you're
It really is.
really
I mean, you
matters.
watch the body language, you see things that,
Yeah.
face to face. And that was one of the things that, when we were having to do a whole lot of this during Artemis, when we had the COVID and a lot of things, and we were trying to work from different locations. That is one of those things that we always worried about. Are we getting everybody involved? When we aren't face to face, are we good? And, majority of our reviews, we worked out a way to have them face to face, but we did have to do a whole lot more, where we learned to do a lot more where you were more virtual.
Yeah.
But even then, it is bringing out the opinions, getting people to speak up, talking about it. And, it's one of those things we can't have launch fever. You can't get so in a hurry to make a milestone that you don't cover the bases.
This is a real good time, I think, to mention the whole idea of testing by engineers. And we talked about the Germans like to test, but the public's attitude about testing is, if you test and it doesn't work, or it fails, or there was a problem, failure. These people don't know what they're doing, but those failures, that's why you test, right?
Absolutely.
I mean, I don't know how we got from the you test to find out to you test because you don't make good stuff.
Right. No, testing to learn is the point, and I think you made. If you think about even in college or whatever, where'd you learn the most when you took a test? When you made the A or when you made a D? You learned the most when you failed, because you were like, "Oh,
that gives me a queasy feeling to think
I
about
didn't-
it
It does
that
me
way.
too.
I didn't know what I didn't know."
Yeah.
Right. And so learning that hubris is not a place. We got to be continually humble, realizing we don't know what we don't know, and being curious about that technical curiosity again.
Yeah, and there's so many things like you mentioned Mike Rudolphi. I was in a conversation with him at the center one time. He was talking about all the things with the shuttle, but not that the weather in New Mexico, the weather in Spain, the cloud cover. The water, how choppy was the water in the recovery? Just all these things.
Is there some nut flying in the area?
And
that
he
just
said
wants to be
it's a
close.
wonder the freaking thing ever flies.
Yeah.
And I remember media person got real upset that he said that. But I didn't use that till later. but it is so complex. Mm-hmm. And you said having your kind of knowing a little bit about everything. And I mean, if you're involved, and when you were with a deputy for engineering for Marshall for NASA, you're having to know a lot or some about a lot of different things, and
knowing who to call on when you didn't
that's
know.
got to be uncomfortable as an engineer, though, where I know this, but I don't really quite know it. I can't concentrate on that one thing. Is that
Well, that's
is
where
that
you can't
tough?
let your hubris get in your way. It used to be a lot of you had to know everything about everything and speak up. I think one of the things that many engineers, and when I go and talk to younger engineers and try to talk to them about different things, yes, you've got to be competent. However, don't forget to rely on your team. You can't know everything about everything. So it is very important that you're able to get the best opinions out and get people to speak up, because you can't let your ego get in the way and say you know something that you don't know. It's okay to say, I don't know, but I will find out. Or I literally like to say, let me call a friend, and that's one of the reasons from a lot of the reviews and different things is to make sure you had the folks that you knew were the experts in the room, so that when you needed that information, you could call on them. They were ready to call you. You talked about it. But yeah, when you're getting ready to push the button, you don't always have everybody right on your shoulder, In a launch countdown, you've got everybody on a headset. And so that's the other thing that we practice is being able to communicate, whether you have a headset or you're in the room with someone. And, that's important to be able to learn how to speak up, when to speak up, and how to get your message out.
Okay, both of y'all when y'all started with NASA, computers were a thing, but not the thing they are now.
There was no personal computer.
Well, no, but there were
There were beginnings.
There were computers.
There were mainframes.
They're big,
but
not on your desk. I remember a
not on your
DG was the
desk,
first thing that we had
Still
on our
had a
desk.
typewriter to
and
get your
AI
charts.
was in science
And a little
fiction.
calculator.
Was in
yeah.
science fiction movies.
Right.
But so you saw change from the early days of being able to rely on computing power to now.
Oh, yes.
When, digital engineering is a thing, and and it's been a thing for a little while. So, in your minds, did it make it infinitely easier, or is it just another complication that you have to take into account? I'm not sure I asked that right.
Well, I was
going to
say one of the things that I look at when, learning how to do the computer, when being younger back then and being trained on a computer, personal computer, or being able to do the things, that was one of the things that as a younger person I could bring, where I wasn't scared of a computer, where some of the folks that were sitting side by side with me maybe had calculators, or they had different way of doing things. And so we could combine their knowledge, their expertise, their system thinking with some of the expertise to expedite some processes. And those combination of the two made us more efficient and effective. But one without the other, it would be tough. That's the way I look as technology evolves. As we see our workforce now that's coming in, where they are more comfortable with a lot
Every
of the
12-year-old is ready.
We're more comfortable in many of the things, to me, taking that into account. And I see that with the model-based systems engineering, the AI, the database, the transformation. I see that as another opportunity where the things that took us time, yes, you can't just leave your brain at the door. There's you got to check to make sure it's right, or you've got to understand the logic behind it. As I like to say, garbage in, garbage out. But when you have that expertise with that ability to expedite and utilize those two strengths, then you take leaps forward. And to me, that's a lot of where we're at. Chris,
Well, just tools in our toolbox is the way I look at it.
Tools in the toolbox.
In physics in high school, I had to learn to use the slide rule before I could use.
There's a couple on the wall.
Yeah, before I could use a calculator, and then we have a mainframe computer, and now we've got personal computers, and now we've got models that we can actually simulate things with. They're tools, and we have to learn how to embrace the tools rather than thinking it's going to solve world hunger. It's a tool in your toolbox. You still got to be extremely competent. You got to know how to integrate hardware with each other.
Yeah. So I'm assuming that means that the engineering basics, the probably what would have been the tedious classes in college, you still have to. You have to pay attention to all this stuff.
You can't skip it.
Like if you took thermodynamics, my dad said it was a really hard course. you have to remember that stuff. When
there's some humbling courses out there. Yes.
You need to, well, if you don't have those physics-based understanding, you can't judge the model that you've created, because you're just creating a model. So we need to continue, we got to have those basics. Now, do I have to have diff-EQ or, differential equations? Maybe
please
not.
Define things. I'm not.
Well, it's a pretty deep mathematical model, where you had to create your own model. Well, now the computers will build some of those models for you and run some of the analytical, background. You still have to feed in the basics.
You made me think of a question. Does the technology, it doesn't force you to, but does it maybe give you too much of a chance to take shortcuts, to not pay attention to some of the things, to the basic math, or to be in a hurry? Does it, because there's so much computing power and AI out there, could it make an engineer maybe not follow all the steps that need to be followed?
I think you have to be careful. I think there are, just like we were talking about, just think about your phone with spell check, or you think about a computer. If you overuse it, then sometimes you yourself lose some of your skills of how to spell things and how to do things. So I think it is important to keep your skills honed, but then also understand, maybe not every detail about it, but to understand, is it giving you a logical, good answer? Is it helping you? Because I think it can help you. This is like you can use it to be, is like I'd say a spot check to say, I believe this is it. Have I done it right? Have I worked through this? So I think there it can be a good balance and check to help you. I think anytime that you just rely on something 100% and don't check it and just assume everything about it is perfect, we're not to that stage yet where computer models and everything know everything that a human knows and can look at stuff and diagnose some stuff. So I still think that human element has got to be there, even though we can use technology to help us go faster.
I love the idea of a digital assistant.
Yeah,
Okay,
digital.
a lot of our work can be somewhat tedious, and therefore you could have a tendency to make an error.
Yeah,
right?
make manual
if you're
mistakes.
not paying attention as close as you were because there's a process that's going on. If I have a digital assistant who's doing some of that less prescriptive work,
Just doing like the calculations.
The
I need you-
calculations. Maybe
I
some
need
of the
you to do
tedious stuff, yeah.
calculations.
not having to do the creative thinking. Give me room to
Yeah.
do the creative thinking, and have my digital assistants build the model.
Okay, so this is much more in writing. I mean, you can read an article about this right now today because I read one about how using AI, like college professors are now going back to the blue book test, where you have to write it by hand. You can't type it. You have to write it by hand because they believe that people are using AI too much and are losing the ability to think. Now, could the same sort of thing happen for engineers, or is that just, writing something or taking a test are different than could AI get in the way of being a good engineer?
I think it could, but I don't think it will. And here's why. Engineers choose to be engineers because they want to create. They don't want somebody else creating for them. They want to create. They come out of school, they get frustrated if they get put into, here, study this set of documents so that you'll be smart enough to start asking your first question. Engineers come out of school ready to build stuff.
Yeah.
And that's, I think it's a mindset that is in your gut. And you'd love to have better tools like an AI, like a digital assistant, but I don't think you'll let it do the work for you. But that's my opinion.
You agree?
Of course. No. No, I do. I do. I just think there is still, we do have to be careful. We have to be aware of not over-relying on some of the digital material. Because, again, one of the things that I've found my whole life is there's never a limit to the amount of data, the amount of information you get. The key is being able to assimilate that data and get what's the useful, the most important to help you make decisions. That's where I do think, if the screening is correct, then that's where this plethora of data that we have, where you can get overload of data and can't make a decision, I think that's where AI and a lot of the activity can help you parse through the information to be able to go forward. Because I know, even me in my lifetime, sometimes you have things presented to you and it's so overwhelming till you really don't know the urgent from the important, or nice to have versus got to have. So I do think being able to have that, and that again comes back to the training of the individuals and the effort we put into people to be a system thinker, because I don't think the data that we're getting is going to reduce. I think more and more our capability, there's going to be more and more data coming at us. So how are we going to take it? How are you going to store it? How are you going to position it so that when you need it, you can get to it, you can access it, and it helps you be able to parse through what's important versus just giving you data overload.
Okay, so back to Mike Rudolphi one more time. He said this to me more than once, that rocket science is hard.
Absolutely.
And we'd be talking about, I'd ask him a question about, well, why can't we just use our old rocket? Why do we have to build a new rocket and all these kinds of things? So you have all these tools, things have advanced, computers that you probably couldn't have dreamed of when you started at NASA. Why is it still so hard? It is still hard. I mean, why is it still so hard? You have more tools in the toolbox. Why is it still so hard to build a rocket and tote human beings into space?
So I'm going to maybe buck the system a little bit. Rockets.
Now, wait a minute. I want you to be thinking about your counterpoint.
Okay.
Well, I mean, I think we need to look at in reality, rockets are hard And we're getting better at it, especially our commercial partners. If you look at Blue Origin, SpaceX, Firefly, Rocket Lab, they're all building rockets and launching for certain mission criteria. They built into their model a next generation. So if you think about shuttle, that's 70s technology. That's 70s technology. These commercial partners are using 90s and 2000 technology. Decades more mature in terms of manufacturing capability and infusing that sort of thing. We are making the leaps that we've been hoping for in the 70s, but we leapt a long way when shuttle and even Artemis is still flying, legacy hardware. But
that doesn't, just very quickly, doesn't that indicate that it was good hardware?
It's staying good hardware.
I mean, it's like a conversation last night with my wife. We were watching Dr. Strangelove, and the B-52s in that movie, which was made a long time ago, those B-52s, heavily modified and everything changed, are still flying.
Yeah.
So
that first reusable
the old
rocket,
technology doesn't necessarily, even in rockets, doesn't necessarily mean it's not good technology.
Absolutely. No, the first high-performance staged combustion, which is the space shuttle main engine, reusable rocket, was in the 70s. It took a lot of maintenance, but by the end of the shuttle program, it was turning and burning. And that's why it was easy to adapt for Artemis. And you can look at the hardware that's in Blue Origin, and it's exactly what we were designing in the 90s during a technology program. So Blue Origin and SpaceX picked up technologies that we were developing and have applied them in a commercial way. So, NASA did what it's supposed to do. We're leaning forward, we're flying, but we're also pushing the technology forward for industry to pick up. And they're doing a great job of it.
Yeah, by the way, it is important for everybody to know, at least I think, that all these companies, these commercial companies doing space flight or building rockets, a lot of things they got handed to them. Like, here's how you do this. That NASA did the groundwork, and they're the beneficiaries. I sometimes think the public thinks that these companies just started from scratch and look at the great rockets they're building. Well, no, they didn't, did they?
Well, and that's one of the things that, you think about the United States in general, from trains, planes, and automobiles. There's a lot that started. You have to have someone that starts it, invest in it, so that someone sees the ability to make a profit off of it and to see the business case for it. And that's really what we've been doing at NASA. And as you said, it's hard. Cheating gravity is hard. And a lot of the physics still hasn't changed. So the deeper you want to go into space and the more complex the mission, the deeper you want to go into space, the things you have to take with you, those are the things that we keep building on. And so, yes, we're not doing the same old things that we've done way back when. We're building on those missions. We're trying to do more with it. We're trying to go deeper with it. And we're seeing that there's still some technology that is needed to be developed. And that, again, is one of the things I was very proud at Marshall Space Flight Center of us being a design and development center, being able to say, here's the things that become operational. Someone else can do this. Let's hand this off. But these still are the gaps in technology, the gaps in what we don't know, the gaps that we need to go further. And to me, that's where it is a joint effort that we work together and try to get there.
And every time, and this Marshall, NASA has been great about developing things that end up with the general public, but every time we do a project, we come out of it with some product that we don't even know we're going to come out of it with, or we learn things that will help us get to the next step.
Absolutely. Learning organization is important.
And those spin-offs you're talking about are even the choice to do digital digital engineering in the early days. I'm talking about using digital versus all mechanical systems, was a major choice that opened up the way for the computer. Mike Griffin tells a great story about that.
Well, do you remember it?
It basically was that in the Apollo era, the Soviet Union was using primarily highly mechanical systems.
Yeah.
They didn't have any electronics, and we were pulling in the electronics approach into our flight hardware. So it was an integrated system, not just mechanical system, not just latches and switches.
Yeah.
And that choice resulted in a huge investment in chip technology, which
Yeah,
eventually became all of our computing technology.
Okay, one of the things technology brings a lot of things. It makes you a little quicker. I think is that fair to say?
Most
That
instances,
It's
yes.
intended most of the
Intended,
time.
yeah.
but it may make you cheaper, but it's certainly not demonstrated by the amount things cost. Why is that? Because I mean, we've done this. We've done this before. We went to the moon, 50 years ago. Why do we have to build a new rocket to go to the moon? It's like why couldn't we just read up that one? So why doesn't it get a little cheaper as folks who've done this for a living?
What is Well, cheating gravity is hard, number one.
Well, I think that just be a given.
Given, right.
Okay, when you write your book, Cheating Gravity,
Is hard.
it's a great name.
Yeah, that's a great name. I would say that, one of the things that we've always got to look at, depending on what we're trying to build, is what is it we're trying to build? Does it have humans on it? Does it not have humans? What is its mission? And so there's a lot of, as I like to call, the acquisition strategy that you lay out. And you try to adjust how much risk assessment you put, how much, as I call it, the belts and suspenders, things that you do to protect that hardware or the humans. And so we really got to make sure that it's not like spreading peanut butter. You can make everything big, all expensive and cost the same if you treat everything the same. So I do think one of the key things as we're going through our acquisition planning is really understanding what is this mission and what are we trying to do. There are things that we can spend less money on. There are things that we can do it with a lighter touch, less oversight. There's things that we can accept hardware or circuits or parts that might not cost the same. But then there's some missions that we can't afford for it to fail, whether it's got humans on it or it's of such significance that we really do need to put the tender loving into it. And with that does cost. Yeah. And particularly when there's things that we don't know every requirement about it. We know what we might want to do, but we don't know exactly how to build it, to make it work, to do exactly what we want. So there is some trial and error, design and development that happens, that goes through that. And so I think a lot of it depends on what we set it up to do, the amount of money we put out there, and then many of the times I think we aren't realistic in what we say we want to cost and what it's going to cost. We get a little bit of, we're trying to sell it, and there's many reasons. Yeah. There's the timelines, there's political timelines.
Okay, so I want a very quick question about the timelines. I was thinking that somebody told me once that one of the problems we have with NASA and with just human spaceflight in general is timelines that are not realistic, satisfying people who want to know it's going to happen quickly. Is that?
I think there's a combination.
Yeah.
I think there's many of the times we have aspirations that political or whatever there may be out there that, has an unrealistic timeline based on whatever the tenure is of that person or where they're going. And so they want the aspiration for it to happen on their timeline. And that's great because we do want to reach for the stars and do the things. However, if the financial planning or the money doesn't come along with it, or the timing of that money doesn't come along, or if the technology isn't as mature as we sell it to be, then there are things that become roadblocks of getting us there. And then there's just the normal hardware is humbling, and we can have tropical events, we can have major storms.
There is
that comes into play. That all comes together. So yes, I think there is sometimes some over optimism and under pricing of what we're trying to do. But I think many of the times, it's we also try to, in my opinion, we spread ourselves really thin on a lot of things. We're trying to do a lot of things at once that are all of major significance. And so we end up spreading ourselves so thin that many of the times the attention that back in Apollo, when we were going forward with it, and we had 4% of the national budget, and now we have less than 4% of the budget 0.4% of the budget that's not all going on one thing. You know, you don't necessarily have that concentration and you're putting all the effort into one. So there's many a combination of things that happen. But yes, we always want to sell it, we want to deliver it, and we want to do it now.
So wasn't it Mike Griffin who wanted to have a council that governed space flight so we would not have the timeline pressures? We would just decide based on good engineering principles.
You know, the Space Council exists, but it has become, I guess,
an advisory.
It's an advisory council. It would. One of the problems is we're a discretionary agency. We're not seen. And rightfully so. The country has lots of priorities. You know, the DoD priorities are much more fixed and don't get the wind blowing of administration changes the way NASA does. And so.
And that was one of the reasons Griffin,
right,
for his council
Right.
was to not have that.
Right. Because and they had done a trip to China actually years ago to look at their planning and budgeting, and China sets out a 5-year plan and executes a 5-year plan, and then 2 years into it, they're developing the next 5-year plan, and so far they have done that to the point of closing the gap significantly. We had a 30-year head start on Chinese capability. They've landed first time a rover on Mars. That's only the second country to ever do that. And they did it on the first try. Now, no, we're not talking about how they were able to make that gap close, but it has closed significantly. And not trying to be the boogeyman or anything, we, the government, the American nation, need to be aware that we're not going to be the top dog if we don't invest in these kinds of things.
And we weren't the top dog before the moon program. And
Right.
The Soviets
We're
had
ahead.
beat us every step of the way until we decided to go to the moon and put the resources and got the right teams going. And that is when we jumped ahead, or America jumped ahead, and the Soviets, tried, but they failed.
Right.
And that we went to the moon and these other things, because they were hard.
Right.
And that's a heck of a legacy that Marshall or NASA
was a key part of
still
it.
does.
And that's the critical part of the bipartisanship, to try to keep the momentum going, regardless of, if it's a Democrat, Republican, maintaining that. And to me, that's one of the things as Center Director and even Space Launch System, and a lot of what we do is trying to keep that momentum going, keep that so that people understand the benefits to them, that momentum going, that support going, and that our Congress, understand the importance of it, to keep that momentum going, because it is very disruptive if you punch a button and do a do-over, or there's the funding doesn't come, or there's things that happen, because that's major products that you're trying to do.
Changes in direction.
It's changes in direction, and it ripples not only of NASA's budget, about 90+% go out to contractors. It's not civil service employees. It's going out across the entire United States. And so when there are changes, it ripples through everything. And, it hurts our supplier base. It hurts a lot of things. So that consistency also is what helps us not only move forward, but it also helps us with prices. Yeah. And again, that's one of the reasons we've gone to more commercial. It's not necessarily what the government can build it for under a cost plus contract. It is, what is that partnership? What is it that the government can bring and that our commercial partners can bring, so that the government pays for the price that the contractor charges versus being fully funding. And that's one of the ways that we're looking at trying to reduce the cost, but with it becomes a different way of operating, a different way of partnerships.
Okay, so we can't talk forever, so there's 2 or 3 things I want to get to. One, both of you are feeling about this, everybody wants to go to Mars. I want to go to Mars, but there are technical issues that are still to be conquered. Everybody I've ever talked to, including Mike Rodolphe, said those things they will be solved. The technical issues will be solved. But however we do it, well, going back to the moon is going to be expensive enough, but let me just drop back. We need to go back to the moon and do things there before we get ready to go to Mars, don't we?
My opinion, absolutely.
Yes.
We have been living in low Earth orbit for almost 25 years and
Yes.
learning lots about living there, but we can get home in 4 hours.
So if somebody has an
there's-
appendicitis, they're
you're 4 hours away,
Yeah.
and you're getting resupply every time you need it. So we have learned how to operate a short distance away. We're camping in the backyard. When we go to the moon, it's like going to Antarctica. It is a serious shift, right? It's 4 days away on a good day, and
or some days you can't get there at all.
and some days you can't, right? And Mars is closer to 400 days away. So just think about the conversation space, the social dynamics. Even if we get all the technology working, we're putting people in a space alone, basically in a scary environment where everything's trying to kill you. I just think we need to learn to live in Antarctica first, which would be the moon. My analogy for the moon.
And Mike Griffin again, isn't that one of his ideas? That we need to go to the moon, live there for a year, basically without a lot of help. Learn to live
Off the land.
Yeah, with. I mean, you could plan modest resupply, or you could plan, depending on how much money you want to spend, you could send a rocket once a week. But we know that's not practical. But we have to learn to live somewhere before we.
Well,
make
and
the
there's
big
still a
trip.
lot of simulation. I mean, we're
Yeah.
increasing the amount of time on the International Space Station,
Yeah.
but there's still things there that you can't simulate totally of what would be the moon. There's things that we're doing today, having folks that are going into environments where they're living on the Earth, but
Yeah.
they're contained like they're somewhere else. But there's still the difference of you can build down and you can, just like testing, before you fly, you can take a lot of the risk away. You can learn a lot and make you smart about a lot of things so that it's not all at once where you're having to learn it. So you can build on that, but then there you reach a point where you do have to, as I'd like to say, push the button and go and live in that environment where you can't simulate it. It is different. There are
And your
technologies.
mindset has to
your
be-
mindset
yeah,
and
yeah.
learning the things that you don't even know that you don't even know. It's kind of like,
Yeah.
packing yourself as he was talking camping. If you're going to go in the backyard, you have facilities inside, you have water, you have food you can go in and get. There's things you pack, your sleeping bag, mosquito repellent, or a flashlight. Well, if you're going into the woods that's 2 days away, you're going to pack a little different.
Yeah.
You can only take what you can carry on your back, so you learn how to do that. Plus, like you said, if things happen, you've got to be able to survive. Then the deeper you go into the wilderness where you're going for months at a time, there's different things you learn and you carry. There's some of the stuff that's very consistent that you don't have to redo, but yet you do have to learn what you've got to take that's going to be the difference
Yeah.
between survival.
So we-
and then throw in science. And you want to do something while you're there. It's not just about seeing the scenery.
You're just not going to go live in a house. You've
Right.
got to maintain
what
the
is you're gonna
house
do,
and-
so-
and what do you do for a living?
Right.
Like-
Yeah. What are you going to make? What are you going to do?
Yeah.
How are you going to live? So there's a lot of that comes with it that I think is a lot of things that we've got to think through. And yeah, that comes back to proving it out on one space, even though you may not can prove it out totally. You learn from it and go farther. And, the big thing is not just to get one space and stay there. We do want the ultimate destination of living and working in Mars,
Okay, so I want to ask y'all just a couple of quick answer questions. How long before we have a habitat on the moon? And you guys know more than pretty much anybody I've talked to. Not asking for an accurate, this is when we're going to do it, Steve, but how long before we have a habitat on the moon?
Just a habitat?
Just before we have humans living on the moon and staying there, before we have a presence on the moon for an extended time. How long? Just guess. I mean, I'm not.
I think it's 2032.
Okay, so
I was going to say in the 2030s.
well, 2032. That
Not too far off.
to remember that.
Yeah.
Okay, how long before we have a presence on Mars? And this is who could know that?
I know, but
Well, we already have a presence with,
No,
without
I'm
humans
talking
on
robots.
Mars.
Okay, a presence with, like, there's a new horror novel out called The Exiles, which is about some people in AI messing them up on Mars. but how long before we have a living presence on Mars? Where we
A
have
sustained living
a
presence?
sustained
A movie
living
like The
presence on
Martian?
Mars. Like The Martian,
Like The
only
Martian.
only without
Yeah.
all the trouble.
Without the trouble. That's in the 2050, 2075.
Okay.
It's
20
I
okay.
just can't see it in.
Okay.
in many
Now
decades.
I think, and a long time ago, well, 20 years ago, I remember running into Ernst Stuhlinger, and the parking lot of the headquarters building at Marshall, and I'd been inside interviewing somebody, and Mars had come up, and I asked him about it, and he started laughing, and he pretty much said 50 years. He said, and this was 20 years ago,
Yeah.
so he just said they're just things that have to be done first.
And definitely that's where we are even today. There are
Okay.
things about propulsion. There's things about
And we're
communication.
working on different
that we
new-
have to conquer
Yeah.
before
But
we
these,
can
but
go.
the great thing about the technical issues, not the human issues necessarily, but am I correct? As two engineers, you guys believe the technical issues can and will be conquered.
Absolutely. I think the harder part is why. I think nationally we went to the moon
Yeah.
for a reason. The why was got behind, and we went. We had a mission to complete in a timeline on a particular window. The why for the space shuttle. This was to create that next generation of reusable space flight. The why for the space station. This was to learn to live and work in space so that we could then learn to do the next thing. So the whys matter, and why the moon, I think, is generally clear, but it's not nationally agreed to.
No, but isn't, if you think about all human progress, the why almost always is because we haven't yet. The wanting to see over the next hill, isn't that?
There's a little bit of that. I'm 100% agree with you, but there's also I want to say power and
competition.
power and competition.
I wanna be there
Do we
first.
do we have to have competition?
I think we
one thing I
have-
loved about the movie The Martian was the fact that at the end,
It wasn't a competition.
to bring a human being back, which was incredibly expensive and just massive resources used, but we did it because it needed to be done, and there was people that there's at least one place where we can get together and do
Yes.
something outside ourselves.
And that's one of the things that, with no barriers, being there, and I think that's what's going to take, is that global cooperation and putting aside some of the differences to be able to do that. But I would come back and again say, it's kind of like being on an airline. If you're in the middle seat, if you can get there first and establish your position, then you can make friends with everybody to your
No,
left
no,
and right. But there is something to be said of having the ground, having the opportunity to establish your position so that you can work as equal partners to get there for the success. It's a little harder when you're many steps behind.
Okay. And this is a question that I asked, and Mike Rudolphi, again, he said it'll happen someday. And an astronaut, Mike Foale, and I know y'all have to know him. Mm-hmm. He was my favorite astronaut because he was so candid. He was favorite to interview. But he talked about when you see science fiction movies, the spaceships are reusable and they look kind of worn. They're like a used car. When will we get to the point? And this is a nearly stupid question. When will we get to the point where our spacecraft will be like that? where we'll be reusing them and space flight will be routine. 2070 to get to Mars. Will we ever get to that point?
I think we'll be faster than any of those, because there are companies that are actively working from an international perspective. You think about Sierra Nevada and what they're building with their space plane, and then you got Starship, which is intended to be reusable and landed, and they learned a lot from that last mission on heat shields and what works and what doesn't. So I don't think we're more than a decade out
before we start having
reusable, the next generation of
looking
reusable
stuff.
Well, and X-37, which is it's not a human rated
Yeah,
but
yeah,
the X-37 vehicle does come back, and
That's the military.
That's the
And it looks
military.
like a small space shuttle.
it's a small, really came out of the 1990s technology development we were doing here.
Okay. All right. Last question, and this is for both of you. Something you have learned a truism from being an engineer working on spaceflight. Something, say, Steve, this is the thing I learned.
I was going to say, always to be curious and to ask. To me, that is one of the important things, that you don't always know everything about everything. So it's always important to ask the dumb question or ask the question and to go forward, because that opens up conversation and you learn more that way.
So mine is actually that it's hard to walk into the fog as an engineer. And what I mean by the fog is that uncertainty, that not knowing, and yet still leaning forward. I had a quote I used on my door, which it was even the turtle has to stick their neck out to get across the road. So even if you're moving slow, you still got to stick your head out. Space has taught me how much we do have to stick our neck out beyond what a traditional engineer is building, where the consequences are less severe. We have to lean into it a little more, which can be a little scary, a lot scary.
I'll lean it into anything.
Absolutely.
Being a football fan. No. Anyway, thank you, y'all, for being with me. This
You're very welcome.
This has
This has
been a
been
lot
fun.
of fun.
Yep.
Hope something good will happen when y'all come back and we can talk about it.
Absolutely.
Appreciate what you guys are doing.
Well,
Yeah,
we're
thank you.
fine. All right, Jody Singer, Chris Singer, thank you for being here, and thank you for being with us. And this is pretty cool. In any case, don't forget, it works.